Okay, hi, welcome to the screencast for question 9, 2014, paper 1, leaving cert ordinary level. And this part A is worth 15 C marks. Now, like always, I suggest you pause the video, have a go at the question, and pause each part and have a go before we look at it, and we'll work our way through. So, assuming you're back, if we want to read the question now, a small rocket is fired into the air from a fixed position on the ground. Its flight lasts 10 seconds. The height in meters of the rocket above the ground after t seconds is given by this equation here. So h stands for the height, t stands for time. I can do this straight away. It's a quadratic equation because it's power of 2. Now it's not y and x, okay, but you can, it's just two the variables don't really matter, okay. So we have a table here. Complete the table below. They're giving you the time in seconds, 0, 1, 2, 3, all the way through to 10 seconds. We have to fill in the height. Now they give us 4 seconds already filled in. If you want to check this right, put 5 in instead of t. That'd be 10 times 5 is 50, minus 5 squared is 25, so 50 minus 25, yeah, that works. You check that once to make sure that's what they're doing, but that is what they're doing. Put it in the calculator, suppose 0 in. Okay, and if you put 0 in, the height should be 0. Put 1 in, 10 times 1 is 10, take away 1 squared is 1, so that'd be 9, I think. Okay, and you continue now. We choose the calculator and just change the value of t each time. When you do that, okay, I'm reading the sample calculation so the person knows what I'm doing, the examiner, and I've put in my different values all the way through, and I've got them in bold just to highlight the ones that were different than the sample heights given. Part A, 15 easy marks. If you think about it, all you're doing is doing simple calculations to fit in a table. We're then asked to draw a graph in part B to represent the height of the rocket during 10 seconds. So this is a label graph. We don't have to label it, and it's already deviated into parts. Okay, so they're going up by 1 box for each unit on the y-axis or the h-axis. 2 boxes for each unit on the x-axis. In this case, it's called the time axis. Now, you should expect with something like this, it's a realistic situation. So it's a missile, a rocket, whatever, being fired up in the air. So after at 0 seconds, it's out on the ground. As it's fired, time passes. So it's going to go up. Okay, at some stage, gravity is going to stop it. Okay, it's going to hang in the air and then come back to the earth, be pulled down by the force of gravity. Now that shape creates a quadratic. Okay, and it'll be a negative quadratic. If you look back at the question, it is a negative quadratic. Okay. So I have the graph, I have the table, just a matter of fitting in the data points. I'll get it started. So 0, obviously when it's first fired, it's at 0 height. Rises in height, okay. You go up first unit, 1 is 9, etc., etc. Okay, you draw a curved line through it to reflect the quadratic. Do it in pencil in case you have to rub it out, okay, and go at it again. And that's that. Now I already have the answers for some parts filled in here. So it looks a bit messier, but that's what your graph will end up looking like as such after you've done all the parts CD, whatever. Now again, 15 marks. Okay, happy days. Okay, it's just drawn a graph. That should be like bread and butter for us. Okay, so part C, 1, 2, 3. Now there's 5 marks for each part. They're all B scales, so it's something. There is an attempt mark available. We're using our graph to estimate, first of all, the height of the rocket after 2.5 seconds. Now, if you see it, I kind of have a tightened screen grab I've put in here. It might be very small. If you do need to refer back to the previous page, it's fine. But I found where 2.5 seconds is. I brought a line up using a ruler. Okay, I want to be as accurate as possible to where it hits the curve. Bring it across to where it hits the y-axis, such or basically the height, the h-axis, the height axis. And I'm reading that off as now 19. It's probably around 18.75. Okay, there will be a tolerance. Okay, everybody's graphs will be slightly different. No, okay, I've rounded there to 19. That's probably taken from the marking scheme. Now my graph would reflect that as not being 19, and 19 is like where that the pointer is as we speak. Okay, so you probably should be better off actually giving that 19. Yeah, okay, giving it a value of 18.75. It doesn't say to round to nearest whole number, which is basically what I'm doing. Anyway, the part 2 there, the time when the rocket will again be at this height. If you think about it, okay, it goes up, slows down, stops, and comes back down again. So it's going to pass through the height again. extend your line across. Okay, where it hits the axis, bring it down. I'm going to put that as 7.5 seconds. Okay. Now the coordinates is the highest point reached by the rocket. If you can see it there, that's the highest point. Bring that line down there, and I probably should have detailed that. Okay, with a line to show my work. Okay, dotted line. I haven't, but I probably should have. So it's 5 on the t-axis, 5 on the x-axis, and now I'm going to ballpark that. It's been 25 over here. Okay, it's supposed to be a straight line. There's a prime example where you should use a ruler so your work doesn't look messy and silly. That's part C. So we're at 15, 15 is 30, and 15 is 45 marks. Keep going now to part D. Okay, there's a 1 and 2 here worth 10 marks overall. Find the slope of the line joining these 2 points now. Bread and butter. Okay. The passives are the formulas like the equation, line, circle, all those things. We've had numerous versions of it over 2016, 2015 papers. It's something from junior cert. It's something we just need to know. Okay. So let's show the calculation. It won't take long to do this. Have the formula. I've identified my points, label them, put them in, do the math. Okay. Put the whole thing in the calculator if you want. I end up with -3 as the slope. Okay. But just be careful you don't make a mistake in calculation, just lose marks that way, but we'll assume that the calculation is right. Now, would you expect the line joining the point 721, 816, okay, to be steeper than the line joining 624, 721? So basically, would this line here they're talking about, would that be steeper than the slope we just calculated? Okay. Would have a value greater than 3. Now, a negative slope means something's going down. A positive slope means it's going up. Okay. But if you have a slope of, say, -1, it might be like that. -2 like that. -3 like that, etc. So do you expect the slope between those 2 points to be steeper? Now, give a reason for your answer. Okay. If you look at the difference in the y values here, 24 take away 21 is a difference of 3. 21 take away 16 is a difference of 7. Okay. So your y values differ greatly, and therefore it should be steeper. Okay, now I've given the actual calculation, no harm. Okay, it's an easy calculation to do, and I've proven that the slope is steeper. -5 is now not larger than -3, but in terms of slope it is. Okay, so that's D part 1 and 2. Another 10 marks or 55. Now part E here. Okay, so first thing it says find dH/dt. Now, I immediately see that and go, well, we have to differentiate. Okay, may not be as obvious, especially when you just say dy dx. Okay, now we'd use dy dx if our 2 variables were y and x. In this scenario, our variables are h and t, so we use the symbol, I suppose, the notation dH/dt. Now, if I go ahead and do it, okay, so I've got the equation that I was given in part 1, or the overall equation for the movement of the rocket. Differentiate, so 10t becomes 10, the t drops away. The -t squared becomes -2t. The power by number in front, 2 by -1 is -2. Take 1 from the power, 2 take away 1 is 1. Job done. Okay. Now, second part there, hence find the maximum height reached by the rocket. Okay. Now, this is max and mins again, and in 2014, max and mins have came up in just paper 1 3 times. Okay. In not like, I suppose, variations of the classic sense. So my slope equation, I just found that, okay, when you differentiate, the reason you do it is to find the slope. That's its function, okay? So the dHt stands for the slope. Slope equals 10 minus 2t. If I'm given a value of t, I can find the slope at that point. If I'm given the slope, which at the maximum height, the slope will be 0, I can calculate the time that it took to get there. So this is an equation of one unknown. Bring the -2 across, becomes 2t. 2 times some number is 10, the number has to be 5. Okay, now it says, that's the answer, so let's find the maximum height reached by the rocket. No, I haven't finished it off. Okay, for whatever reason, I found the time it took to reach the maximum height, not the actual maximum height. So I've lost marks there, but if we finish it off here, the height there is given by, it's 5 seconds, so it's 10 times 5. Now, I probably could actually use the table, but let's just calculate again. -5 and the squared. Okay, That's going to be from 50 minus 25, so the maximum height is equal to 25, and that's going to be meters, isn't it? Just check the units, make sure it is meters. Oh, sorry, I'm just back here. And yeah, the height is in meters, just to make sure the units will be what a mark, okay? Now, the maximum height you see it, 24, 25, 24, is it's going up and down, okay? So that it is correct. Okay, I'm surprised I even asked you that. Anyway, so my answer was short. I should have reread the question. Okay, of course, I did that on purpose to catch you out and show you the mistake. Now, part 3 there says find the speed of the rocket after 3 seconds. Okay, now the dH/dt formula is the slope, but the slope in essence references the speed of the rocket. At the maximum point, the speed is 0. The slope is 0. Okay, so speed and slope are synonymous in this sense. So I have my slope equation, my speed equation. I'm asked to find it after 3 seconds, so I put 3 in. Excuse the tightness of this, but it's 10 minus 2 times 3 is 10 minus 6, which is 4 meters per second. Okay, job done. Now, part F should be almost there. Okay, I should go straight to the answer here. Find the coordinates of the point at which the slope of the tangent to the graph is 2. Okay, now 2 is a positive slope, so it's going up. If this is just an infographic showing, not this particular function, just that function. The b slope there, that tangent here would have a negative slope. That tangent here would have a positive slope. Okay, so find the coordinates. There's an x and y, or h and t, depending how you look at it, at which the slope of the tangent to the graph is equal to 2. So I have the slope equation already calculated. So I'm told the slope is 2, so I can put 2 equal to the equation. And that's what I've done here. Now that's an equation of one unknown. Let's solve for t. Okay, I bring the my negative 2t across becomes positive. Bring the 2 across, the equal becomes negative. So 2t equals 10 minus 2, which is 8. Now 4, obviously 4 is equal to the time. So 2 times some number equals 8. That number must be 4, positive 4. Now that's the time, that's the x coordinate. I need the y coordinate. Okay, so 10 times 4 is 40, minus 4 squared. So I'm putting the 4 seconds into the original equation as, in essence, to find the height. Okay, put it to the calculation and I get 24 meters. So this 424 is the coordinate. And I probably should have put it in the coordinate form and declared that as my answer, just to be best. Okay, obviously you're right, it'll be better than that. Now, sorry for messing up the screen, but that should be F. Okay, it's the end of it. Okay, so that's the end of question 9. It's the end of our screencast for 2014. Again, like always, the advice I can give you for any paper is know your methods. Okay, the trick always is to know when to apply a method. Practice makes perfect, but at least be aiming for these attempts. Okay, in this scenario, you know, any use of 2 for slope would get you something. Okay, so just try getting those attempts on the questions that were successful and get good marks. That'll boost us up. Okay, so I won't go any longer. Thank you very, very much, and see you on paper 2.